In this short video, we're going to introduce the idea of compilers and interpreters and how those relate to Java in what's called the Java virtual machine. So the vocabulary we want to focus on in this video is compiler, interpreter, JVM or Java virtual machine, and bytecode. So what are compilers, what are interpreters? The way I like to think about it is sort of from a human perspective. Imagine that you had a book that was in a language that you didn't know, so you couldn't read this book, but you had a friend who could. So let's say, just pick a language. Let's say the book is in Russian and you don't know Russian. So your friend does, and so there are a couple things you could do to have your friend help you with this book. You could either have your friend kind of read the book to you line by line with you there, or you could give your friend the book and he could write out the entire book in English, translating the entire thing all at once for you. So that second case is what we call a compiler. So a compiler takes a computer language that is written, like Java or C or Python, some language that is written by a human, that's called source code, and translates it all at once into what's called machine language. Machine language is what the computer itself, the hardware, can actually execute. And so a compiler takes all of that source code and turns it all at once into machine code and saves that, and that ends up being what the machine runs, not the source code itself. Down here, this also checks, this should say syntax. Syntax is the grammar of a language, so it makes sure that the programs are written grammatically correctly, if you will, and that all the things that need to match up. So compilers do two things. They check syntax, make sure it's grammatically correct, and then if it is, translates the source code into machine code. An interpreter, on the other hand, is what would be happening if your friend were just reading the book to you one line at a time. An interpreter looks at source code one line at a time and then interprets that in a way that the machine can understand, executing it again one line at a time. Interpreted languages tend to be slower because they're not running directly in the machine's language. You have this intermediary, this interpreter that's having to run as well. But they have their advantages too. So Java, interestingly, is a combination of these two. Java, you write your code in Java itself. There's a compiler called JavaC, and then that compiler turns that Java source code into what we call bytecode. Now, bytecode is not human readable. It's machine code for something that we call the Java virtual machine, which is a machine that's actually not real. It's implemented in software. And the Java program itself then runs the bytecode, interpreting it into whatever hardware you're actually running Java on. So it's kind of like a three-layer process. And this is what makes Java cross-platform and very portable. Any hardware that has the Java virtual machine program written for it can run Java source code. And so that's the real big advantage of Java is that virtual machine, and the fact that in order for a new piece of hardware to run Java, someone just needs to write the Java virtual machine for that program, and then all existing Java code can run on that new device. That was sort of an innovation that Java had come up with to make things cross-platform in ways that other compiled languages weren't. So this isn't something that we have to really overly concern ourselves with, but you should know when you try to go and run a Java program that you write, there are a couple steps happening, right? First, JavaC, translating that into bytecode, and then Java running that bytecode. Incidentally, so your programs that you write will all have a .java extension. So when you write source code, it's in a file called whatever name .java. When JavaC processes that file, it produces another file called that same name but .class instead of .java. So these bytecode files are in .class files.